Let me start this thing off. Now I mentioned this quote in my keynote this morning, but this spoke to me on a really deep level. That Linus Torvald said his job is to say no. His job isn't to create amazing things. I remember years ago, Linus has this great way of occasionally getting on the mailing list and just being really irate, and I love it. It's great. I think I'd even be okay if he was yelling at me. I just love to read these. Years ago, he was irate about why suspend and sleep didn't work for laptops in Linux. And at the end of his rant of here's all the things you guys are doing wrong, he said, "You know what? I'm just going to not merge any code for 2 weeks. I'm going to solve this problem myself." And guess what? Since then, we haven't had big sleep and suspend problems in Linux because Linus said, how about I just stop saying no to people and just write some code? One of the one of the things that I'm running into, and that a lot of us have run into, is that when we build software today, we are not being asked to build rinky-dink software on a regular basis. We are being asked to build aircraft carriers. We are being asked to make big pieces of software. And to make big pieces of software, the most difficult thing to scale isn't the systems. It isn't the data. We can come up with distributed indexing algorithms. The most difficult thing to scale is us, is people. Who here has read The Mythical Man Month? I feel really old. I think that book came out in 74. The Mythical Man Month is an old computer engineering book where it talks about, hey managers, just so you know, we understand that if you have an assembly line and you want it to double your performance and you have 3 employees, you can hire 3 more and you can expect roughly double output. This doesn't work for software engineers. Why doesn't it work for software engineers?
The same reason it doesn't work for. If a woman can make a baby in 9 months, then 9 women can't make a baby in 1 month. Some things take as long as they take.
Thane up here just said that it takes a woman 9 months to make a baby, and you can't make a baby with 9 women in 1 month. And I'm going to counter that with Solomon said we're going to cut that baby in half. And that's actually what we're talking about here, is how do you cut a baby? Yeah, Thane, shut up. What makes it so that people don't scale as well when they're engineering software? As software engineers, we can keep a certain amount of a code base in our heads, right? We can say, look, I know where all the bodies are for so much code. I know where all the paths are. And when we can keep it in our heads, we can solve those problems quicker. And when you've got a smaller code base, it's fairly straightforward to bring somebody up to speed on it. If you've got 5 to 20,000 lines of code, you can sit down with someone else for the most part, and they can own that code in a couple of weeks if they're a good engineer. But if you've got something the size of Salt, it takes a while to bootstrap somebody on it because it's a million some odd lines of code. And so if we want to be able to make humans scale better, we need to break up our software into more small pieces. Because again, it's so much easier for us to manage software this way. And we've seen this with the microservice movement. a lot of what I'm going to talk to you about may feel familiar from a microservices perspective. But if we do that, then the people who understand the code and can innovate and that are creating new things can create more new things. They can manage and maintain more things. And it allows more engineers to focus on creating next generation software, because the maintenance burden should go down when we've got smaller individual pieces. Okay? And so, how can we do this? This is where this idea of POP comes from, plugin oriented programming. The idea is that the Salt loader makes Salt incredibly extensible and incredibly pluggable. And I can't tell you how many times somebody has answered the question, what do you think is the most important or most insightful thing inside of Salt? And they say it's the loader. They either say that or the prolific use of dictionaries. Okay, I got a few chuckles. So, a few years ago, I thought to myself, I got to write some code at night. This is what I love to do. What would it look like if I took the Salt loader and I broke it up and made it a standalone just thing? And so I just tore the Salt loader out and made another project. I called it Pack, and I thought, how fun is this? That was an enjoyable few evenings. And like many enjoyable few evenings go, it led to deeper long-term commitments. Now, well, that's what happens when you write software in the evenings. So I looked at my standalone version of the loader and I thought, what would this look like in a different programming language? And so I beat on it and wrote it kind of in Go, and played around with it in OCaml, and did a little bit with it in Nim. And then I found this cool language called Julia, and I got it to work in a totally different way. And it kind of opened my eyes to what the possibilities were. And so then after that, I came and re-implemented it from scratch in Python with what I'd learned on my journey. And I realized that what I had produced wasn't just a plugin system. It was really a new way to write software. And so then I went out and I made a bunch of little applications and played around with it until I'd refined the idea enough, and then bounced it off and worked with a few other people. Dave Hilton back there helped a lot to really refine this idea to the point where I felt it was mature enough to actually present a programming paradigm, this is on that laundry list of things that we tell people, no, don't build that. That will ruin your life. Okay. And so POP revolves around a few really important concepts. One is that we can manage large code bases and complexity with large teams if they're broken up and they're pluggable. Okay. Another is that it's all about the visibility of the application. Inside of POP, all of your application should exist on this hierarchical namespace, which solves a number of problems that we run into with the Salt loader. But it also gives you better memory management because you're able to say, my entire application exists on a searchable hierarchical path. Okay? And then there's this thing, I've got 3 subs and patterns. And so what this means is that a sub is a plugin subsystem. So in Salt, we have lots of plugin subsystems. So that Dunder Salt that you deal with, that's a plugin subsystem. Grains, that's a plugin subsystem. And so POP still abstracts those concepts, but it formalizes something that we do in Salt called patterns. In Salt, whenever we make a plugin subsystem, like execution modules or state modules or grains or returners, etc., they all follow patterns. And they all have their own distinct patterns. So execution modules and state modules follow what I call a library pattern. The grains follow a data collection pattern. Returners follow a pluggable interface pattern, et cetera, et cetera. And then finally, there's this concept of app merging. At first, when I was working on this, my idea was, what if I could make it so that 100% of my application was pluggable? I mean, cool, right? I realized that once I made 100% of my application out of plugins, that it would then seamlessly plug with other applications, so that we would be able to take an entire application stack and merge them with another entire application stack. But then I also realized that if everything is a plugin, then you can have a separate application implement plugins, right? I mean, we do this in Salt. You can write your own plugins and distribute those down to your minions. Well, what if we just formalize that in a significantly more elegant way and installed those plugins via normal Python means? And then the end result is that it becomes very easy to create a separate standalone Python project that fundamentally morphs the originating project, so that you can have external code have really deep impact on its originating project. And so that's what app merging is. So creating a POP project is not too terribly difficult. And I'm going to, should I live code? I really shouldn't live code. I don't have time. I don't have time to dink around looking for a repository either. I'm sorry, I should have had this loaded up. So up here on GitHub, we've got a nice little demonstration repository. What I want to do is walk through just how to use POP in general. Some of the things that I want to make you aware of is that POP makes just building a basic application in and of itself really simple and straightforward. And it allows you, again, to just have everything inside of these plugins. And so if we start with this run.py, so this is just our entry point here. This is the only part of the code that isn't plugins. So it's just bootstrapping the system. So we're just importing POP, and we're making this thing called a hub. The hub is really critical. You can think of it kind of like the self variable, just bigger. And so we make a hub, and when we make a new plugin subsystem, it goes on the hub. One of the problems, again, that we run into with Salt is that we'll make a plugin subsystem like Dunder Salt, and then we want to expose it to another part of the code. And that turns into a fresh nightmare. I mean, it's terrible. And then we do all sorts of unholy things where we make an instance of Dunder Salt and then we pass it along into other areas of the code. So whenever you make a subsystem on POP, in POP, it just goes right on the hub. And so then it's just available to your entire code base. You don't need to pass it around or anything. It's a really slick thing. I've got lots of glazed eyes, like no light bulbs are going off, so I'll just keep going. So when we make the hub, it gives us a POP subsystem so that we can be turtles all the way down, right? And so there's a subsystem called POP for managing POP things, and then a module called sub and a function called add. So we're just saying, oh, let's add yet another subsystem on here called Poppy. When I say poppy.poppy here, I'm giving it a Python path. I'm saying, hey, if you import poppy.poppy, that will lead you to a directory full of plugins. It's going to be fantastic. Go for it. All right. Like classes in Python, plugin subsystems can be initialized. And so if you have an a dunder init function, that init function gets called when the module gets loaded up. This allows us to do things like, well, start things, but more importantly, it allows us to set up environments. So in this case, I've got this line hub.pop.conf.integrate. I mentioned earlier that when you have pluggable code, you can plug entire applications together. If you're going to plug entire applications together, then the mechanism that manages the plugging of entire applications together needs to be able to manage the entire configuration loading stack. Because, they're standalone apps. And then it's got to be able to load all that information into a namespace so that it can be used independently by multiple apps that are merged together. And I know that might sound complicated. It's actually really easy to use. You just need like that one line. It's slick. What this means is that when you create command line parsing and config loading, let me see if I can do this real quick. You've got to take options from the command line. You've got default options. You've got environment variable options. You've got config file options. Your command line needs to specify where your configuration file is. Your configuration file overwrites the defaults. The defaults are configured with the command line options. And environment variables overwrite what's passed in the config file in the defaults, but it's overwritten by what's passed on the command line. Okay? Which is a pain to implement, and every time somebody makes a command line application, they implement that. Usually badly, and then they fix it later. And why do this? So POP just kind of solves that for you, and I'll show you that here in a second. And then we add just another subsystem. And so as you're beginning to see, this hub is really important. Another thing that you may recall inside of Salt is that there's Dunder virtual functions, right? So that you can rename and reload and determine whether or not determine if you're going to load something. POP supports virtual functions. You may have also realized that in virtual functions in the Salt loader, you don't have access to Dunder Salt, right? Because it's a chicken and egg problem. Yeah, not anymore. The chicken and the egg came at the same time, suckers. Okay. So the Dunder virtual function can accept the hub and therefore has access to your entire code hierarchy. So we made another plugin subsystem here. And I'm just making a little RPC server as the demo. And so this plugin subsystem has another Dunder init, and it sets up a web server, and then sets up a router for the web server. So what we're doing in here is you'll notice that I haven't explained to you particularly where this comes from. Like I said, I've got to be able to take configuration information and bring it in. When I called that conf.integrate and said, hey, your configuration magically loaded, well, it's got to actually come from somewhere. When it loads, it shows up on the hub under hub.opt. And then the application name under which it was loaded from. And that's what this conf.py is for, as well as a few other things. You can put all of your configuration loading in the conf.py, and then that conf.py is a special file which is read in by POP to determine the dynamic nature of your application. And so it does everything that I said about config loading. I won't do it again because of, order. And exposes those instantly on the command line. And when invoked, it also sets up all of the options that you to start up a log system. The other thing is that when you install POP, you can install it from pip install POP. It comes with a little application called POP seed that makes all these files for you. All right. Well, that didn't work. What a terrible reason to waste time. So just in case anyone is wondering why my laptop isn't working properly right now, I'm a huge fan of KDE, and I'm currently running GNOME. No, I'm running KDE. Okay. When you run the pop seed command, it makes your plugin directories for you. It also makes a setup.py They will automatically discover everything that you need, so there's a decent chance that your future edits to the setup.py are extremely minimal. Gives you any boilerplate, but it also makes a build.py. You may have thought, hey, Tom, you just proposed that you're going to make a ton of independent projects. That gives you significant problems when it comes to versioning, and that gives you significant problems when it comes to dealing with dependencies, right? Who wants to install 250 dependent Python libraries to get what comes in Salt? And you're going, no, that's bad, Tom. That build.py builds a single binary with all of your dependencies in it, including Python, so it's nice and portable. So that's kind of my solution to that particular problem. Okay, we talked about the hub. We talked about configs. Okay. So plugin subsystems are like containers for your code. They don't necessarily replace the constructs of object-oriented programming. Since I'm talking about the creation of a programming paradigm, I have to address object-oriented programming because, you know, that's the church that we all go to. Everybody's on board with OOP, right? Whether we like it or not. Object-oriented programming is a brilliant and fantastic thing. I don't want to be presenting in a programming paradigm in such a way in which it's construed that I'm trying to badmouth existing paradigms. POP is built on top of using constructs from object-oriented paradigms, and it exposes the ability to use object-oriented programming. Now, my argument is that inside of POP, we have new tools that we can use that can give us new abstractions beyond what we get from object-oriented programming. Plugin subsystems need to be thought of as a macro container for code. And when we do that, we're able to also use that hub that exposes these plugin subsystems as a store for variables and extra data. So that instead of thinking about your code as a collection of object-oriented silos, which is what we end up with when we use OOP, because you get all these instances that have data all over the place. It's important to think about this code, this more of, I've got a hub, and so I want to put my data on my hub's namespace relative to my code. And then I have global access to that data. Now, before you throw a tomato at me, because I used the word global. Yeah, this guy right here, he's got angry eyes. Like there's a knife in his back pocket. All right, sorry, too far. The thing that's bad about globals is that you don't know who owns them. If you have a hierarchical namespace, you can put your objects relative to their ownership, and then use conventions for access. When you make something private, does it mean that another function can't get to it? Ah, thank you. He's laughing. When you're in a process, you have full access to all memory inside of that process. Welcome to how computers work. Don't make things private because it's just you saying, don't touch this, please. That's why Python doesn't necessarily fundamentally care about things being private. Okay. I talked a little bit about app merging already. One of the problems I've got with this presentation is that I am trying to cram 4 presentations into 45 minutes. Next. You have been given a crash course, hyperfast, on some of the basic ideas of POP. Now let's talk about item. So I mentioned earlier that one of the problems that we run into in open source code is that we here at SaltStack and everybody at the Python Foundation and the Linux kernel and basically everybody who's given us really killer code spend an inordinate amount of our time reviewing pull requests, right? This kind of drives me nuts when I'm going, I really want to build something, and I spend all my day reviewing pull requests. And at the same time, I'm grateful for the pull request, don't get me wrong. But I want my cake and to eat it too. Who doesn't? Item is a really good representation of this construct. This app merging thing, like I said, means I can make a separate app and it merges. So remember that. We'll come back to it. Item. I took salt states and I made it pluggable. That's what item is. I also rewrote the runtime and migrated everything to Python 3.6 and higher. And by pluggable, I mean like flipping everything is pluggable. Who here knows what a requisite is in Salt? Man, why is that concept so hard? I'm only at 60% of the room. People hate requisites for some reason until they use them, and then they're like, oh, these are glorious. This is how we should do this thing. And then they're like, no, it has to be imperative, purely imperative. Do you know how to add a requisite to Salt? Say you want a new keyword, right? Because there's require, watch, on fail, on changes. Do you know what has always been done? There's this surefire way to add a requisite to Salt. Who said that? Yeah, that's the answer is you ask me to build it. Yeah, it's pretty tight. In item, requisites are plugins. You can add them all you want, which is actually really cool. Because every now and then somebody's all, hey, I want a requisite that is like require 3 out of 4. Can I get a require 3 out of 4? No, you can't. Because I don't want to build it. But now they're pluggable. So you can add a require 3 out of 4 if you want to item. Okay. I think I already covered these. Item is available on PyPy. Yay! It hardly has any dependencies, and by hardly, I mean like 3. And you can pip install it. So when you make salt states, you've got to, like put them all in /serve salt, right? You got to edit your file roots. You've got to run salt call with -- local, otherwise it hangs. Trying to look for a master, and then you go, oh yeah, I got to put a master up, or I got to run -- local. Item is built as a programming language. All you have to do to run states with item is make a directory with your SLS files wherever you want, and point item towards that directory, or CD to that directory and run item, and you're done. That's it. Okay? Item's ability to gather files is pluggable, which means that you should be able to run item in the future and say git repo, HTTP location, whatever, right? Because that's how we roll. Plugins are great. So it's really straightforward. If we take a look at the item code, you'll see that it has 2 directories that have that you would find familiar. One is called exec, that's for execution modules, and the other is called states, that's for state modules, and they both contain one file, test.py. It's beautiful. And I see some confused looks, and some nods, some wise nods, and some ignorant nods that are going, if Tom's happy, I'll go with it this time. I'll argue with him later. I'm not going to do it in public. It's too embarrassing. So if it's only got that one file, where do all of your files, where do the 700 plus execution modules that are in Salt, where are they going to come from so that we can actually use this stupid thing, Tom? This doesn't make any sense. This comes from app merging. Instead of SaltStack saying, I've got this one monolithic project, like we do with Salt, the idea is, if I want support for a cloud, I will make a repo and build support for a cloud. And then I install that, and Pop magically finds it for me through vertical app merging, which means that that component can be independently tested. That component can be independently developed. That component can receive a pull request and run tests in a very short amount of time, and then it can be merged. Unlike what we have to do now because the code base has just gotten so darn big. And since they can be developed independently, they can be developed like code from any old programming language. I mean, all of us config players have basically done the same thing, where we say we've got our own system for distributing these, and if you want them to be official and real, we must bless them. I'm sick of blessing stuff. Think of it this way. If every piece of Python code had to be merged into the Python base, that would be a hot disaster and completely unmaintainable. And therefore, the amount of possible code would never be written. And this is why we can't have unified API solutions, is because we keep trying to do it this way. Because we don't look at it and say, so we do kind of have a unified API system because every API in the world is expressed through Python if it's a half-decent API, right? So why is it that if I sit down with an investor or a business analyst and say, I want to write a unified API system, they'll just laugh and roll on the floor and kick me out of their office and say, that was fun. Thanks for the laugh, kid. And I'm going, but we already have them. This is how operating systems are built. Anybody can make a package to Red Hat. Sorry, CentOS. Anybody. Let me back up on that one. Anybody can make a package for Arch Linux. After reading 8 different sources of documentation from multiple locations and trying and failing 17 times, you too can make RPMs. But you get the idea. It's all about external augmentation of a code base. Let me put it one more way. Python 3.8 has a feature in it called the walrus operator. To get the walrus operator in, how did we get it? They opened up a Python enhancement proposal. They argued with Guido van Rossum until he decided to retire. And then it got put in the code base. And almost everybody I'm talking to is saying, why do we need this and how does this even work? Who here can tell me how the walrus operator works in Python 3.8? Okay, I've got 4 hands. That sounds about right. Who here is crazy excited about this? Yeah, Eric. Of course Eric is. Under the ideas behind POP, you would be able to create a standalone project that could make deep modifications to a piece of software. So deep that you would be able to add a walrus operator, and instead of going through a PEP process to plead and argue with someone until they break and let you put the code in, instead you can, I don't know, develop your code to merit like everybody else and make a project and say who's using this, and when enough people use it, it becomes a no-brainer for it to be adopted in a mainstream system, right? I mean, when we make a piece of software, we don't then fill out a form and argue with the people at Red Hat until they accept it into Fedora or in Debian. They wait until enough people care. I mean, that's how we've been doing it for years. It seems to work pretty good. I mean, Debian's got how many packages now? Anyone? I don't remember. I thought it was like 60,000. Some stupid number. Okay. How long do I have, you guys? Oh, I've only got 10 minutes? Doesn't give me enough time to give an example. We've got support, preliminary support, don't get me wrong, but it's in there for Azure Cloud and Item. What I would really like to do, there's a few more things I need to add into the POP ecosystem, like a secret store and hooks into the event bus and things like that. What I would like to do is that we migrate the cloud support from Salt to Item so that it doesn't have to be tested along with the rest of Salt and can stand on its own but still be plugged into and callable from Salt. And the Salt Working Group captain and the Salt Working Group have expressed support around this idea, and the working group captain has already migrated Azure support for us. And so, and it was working like a week ago. Okay, this stuff's new. But with that said, there's documentation on Item about how to migrate clouds from Salt to Item so that they can be operated against in a more independent fashion. Okay. Two other things that Item has that Salt doesn't have, because once I tore everything apart, it was a lot easier to get into some of that. It's got nesting namespaces that a lot of people want. So it doesn't have to be just like test.ping. It could be test.foo.bar.ping. Bad example. It can be azure.compute.vm.add or something, right? Yeah, but your local version that has it for years would like that. Didn't that PR break everything? All right, fine. We'll argue. We will argue later, Thane. Okay. I named something in a controversial way. So Heist is my favorite named project. There is a decent chance I'm going to get shot down and have to rename this thing. I mean, but come on, it's a great name. If we come back and we look at Salt SSH, Salt SSH works by creating an SSH connection to a remote system, running a script, gathering data, building a tarball of stuff to send to that remote system, relying on the installed version of Python on this remote system, sending a tarball of stuff down to the remote system in a new SSH connection, executing that stuff, taking data from that execution, and then doing a loop-de-loop. You like execute 5 times over and over again through said connection, sends down another tarball, which has all of its partially compiled state files, which are partially compiled on the originating source of the Salt SSH connection, then executes states and ingests return data, and it is still faster than any other SSH management system. Man, is this just a rough audience, or am I just so tired that my jokes are terrible? Heist says I shouldn't have to have Python on the remote system. I should be able to use Python 3 features on a Red Hat 6 box without installing Python 3. I should be able to manage these systems and still have access to the event bus. I shouldn't have to have huge time penalties just because the only way I can get to this system and manage it is over SSH. I shouldn't have to maintain agents on these remote systems. And I should be able to use that SSH connection for all communication. So Heist delivers. And when it's done, it leaves no trace, like a proper Heist should. Heist relies on this thing called salt bin. Salt bin is a system that builds a single binary of salt with all of the needed dependencies. And when you build that binary, you can choose which dependencies you want to put in and how big you want to make it. And that binary comes with Python, so it can run on an old platform. And there are binaries available on repo.saltstack.com/saltbin. And Megan is now angry that I have published the location of this repo. And she's all nervous because she's like, they're still kind of raw. But they work. Yeah, she's like, yep, they work. We'll clean up those Unicode errors. Don't worry, they don't actually break anything. No, in all honesty, the Unicode errors don't break anything, and they only show up on a few platforms. So the binary that we've got up here was built on Red Hat 6 using Python 3.7. And so it's a build of Python 3.7 that we have automated inside of the SaltBin repo. The SaltBin repo and the ability to make these is available on GitHub. So you can go to github/saltstack/saltbin, and there's instructions there on how you can make your own SaltBin binaries. For Mac OS, you can make them. They'll run on whatever Mac platform. As you're all well aware, portable binaries on Linux can be a bit of a pain in the neck. Really, the solution is to just build it on an older system. There are some Docker scripts on that repo that will do that work for you inside of CentSix, which means that you'll get a binary that works just fine on newer systems. Okay? Except that on Ubuntu, it gives me these weird Unicode errors, and I'm still figuring that out. Okay. That binary. So it's one binary file. So Salt has lots of scripts in it, right? It's got like a master and run. So how this binary works is that if you run the binary space what you want to run, it'll give it to you, okay? So they're all in there. And so if you go and look at the quick start guide for Heist, the quick start guide for Heist says, hey, download this single binary and start a master from it. Now, Heist doesn't need to use a master from a single, you can use a normally installed master, traditionally installed master. Right? I don't want somebody to, what is normal anyway, Tom? I get you. So it can use any old master. But the example for using Heist has you use this binary to fire up a master. When you run Heist, it will double check the repo and download that binary for you for distribution. Or you can make your own binary and stick it in Heist's artifact directory, and your binary will be used for distribution. So that it's easy for you to come back and say, hey, the binary you're providing it's really the basic dependencies are in there. It doesn't have every possible Python dependency in there. And so if you've got special needs for more depths, then it is really easy to make your own binary. Okay, Heist has rosters similar to Salt SSH. And so how Heist works is that you create a roster. It defines all of the targets that you need to hit. Rosters are pluggable. I got one. It's like bowling. Yeah, no, I go bowling. I just get 10, right? I just get one pin. And I'm like, yes, I got one. Okay. Rosters are pluggable. Rosters use the same rendering engine that's used by Item to generate their files. So by default, a roster file can still use templating and all that stuff that you can get from a state perspective. Okay, because when I tore apart the state system for item, I had to tear apart renderers, and so renderers exist inside of their own repo, and so it makes it even easier to build your own programming language on top of item for declarative programming if you're into that sort of thing. So it is like a programming runtime, but whatever. You can use renderers for rosters. Okay. And yes, I took into consideration that security issue with renderers and rosters that we fixed like a year and a half ago in Salt. So how Heist works is it creates a single SSH connection. And then over that SSH connection, it runs some commands to determine OS, etc. And then it sends a salt bin binary over the connection, tosses it into var temp. And then once that thing is tossed into var temp, it goes ahead and fires it up. If systemd is available, it will use systemd to fire it up. So it'll be as properly running as we can do over said connection. When it fires up, it uses the root dir option inside of Salt to make sure that Salt only ever manipulates files for its own consumption under var temp whatever, where it's actually deployed. Okay, so it is completely self-contained. It's not spraying files all over the place. Okay, once it's up, it will connect to an SSH tunnel that Heist has prepared back over that SSH connection to your master, so that the remote system does not need to have independent network access to the master. Everything is still tunneled over that SSH connection. Now you might be saying, but Tom, this would be great. Can't I just use this to deploy these minions to my normal master? Yes, you can. All you've got to do is specify that master in your roster, and instead of tunneling back over SSH, it'll hit that master. Okay? And then if you do it that way, when you close, so if you tell the minions to connect to a specific external master, when you shut down Heist, those minions will stay there and keep functioning. If you have them connected back through the SSH tunnel, when you hit Control-C on Heist and you kindly and respectfully close Heist, I mean, I can't do anything if you give me a signal 9. I mean, just that's how those work. If you close Heist respectfully, it'll clean up all its minions. And it'll be like an Ocean's 11 movie. No, did I go too far? Come on, Jake. Ocean's was great. Okay. I think I'm out of time. I'm out of time. There's another project called Umbra, but I'm out of time. Sorry. Just a quick overview. Umbra is pluggable. Umbra creates a pluggable data flow style artificial intelligence pipeline so that you can connect it to a Saltmaster's event bus and do AI and ML on the event bus, and then take the stuff you get out of it and put it back on the event bus and use reactors and stuff. Y'all up to speed with me there? It's slick. There's a demo directory with some examples in there and docs and stuff. I'm out of time. I can't even ask for comments, questions, arguments, rebuttals, and rotten fruit, but I will. Comments, questions? Sir? Heist is pluggable. Whatever system somebody makes that we can connect over and tunnel through, we can use it. A lot of distributions have been disabling SSH for a long time, like they should. SSH has a number of inherent security issues that people should be aware of. When we come back and when we make something like Heist, I almost want to put a disclaimer on it, just so you guys know, if you're exposing SSH on large scale, that's actually really bad management. But it seems like everybody does. And so it's hard for me to just look at everybody and say, hey, you're all wrong, and expect them to, agree. So I will accommodate your whims occasionally. Does that answer your question? Was that snarky enough? Okay. Any others? I mean, you can go if you want. Any other questions? Sir? How does Salt Bin handle sea-level extensions? It compiles those suckers in. Yes, statically linked. So yeah, they can get kind of big. The default Salt Bin binary that we're making is a little over 40 megabytes. Now, for the fact that Heist only sends it over the wire once, though, and then you've got a standing deployment, it's one of those where, yeah, your initial deployment's a little slower, but then you're running at full salt speed, right? And so I'm kind of looking at it going, okay, initial deployment is about the same performance level of Salt SSH, and then you're at salt speed. Okay, any other questions, comments, arguments, rebuttals? Salt still connects to the Salt master using ZeroMQ and its existing stuff. It just happens to be through an SSH tunnel. Salt runs totally normally. It's seriously the only change to Salt is the config that says hit a tunnel instead of the specific master. Okay, any others? All right, you're all now free to go and insult me on Twitter.